Hi, is this Charissa or someone else? May I know who's at the other end on the DS2B account? Hey, hi, Dinesh. Am I audible, Dinesh? Oh, no issues, sir. No worries. Okay. Did you guys receive the link just now?
Hello, Sanatan. Very good morning.
Good morning.
Yeah, there is a problem with the link on this today also, I think. From the mail itself only, I found it. We will receive that confirmation, right?
Okay.
So from that confirmation, I've joined today.
And that,
Huh.
like, we did not receive any mail today. It's yesterday's mail through which. And yesterday
Okay.
also we got a mail, and then in 5 minutes there was a mail saying there's a holiday.
Yeah, like for on yesterday, I was literally calling everyone in the GUVI that I would know. The coordinator,
Oh, okay.
the yeah, the mentors team, Naveed and everyone.
No, even I got it very. I was actually there in the morning, but then at 8:59, I got a message from one of the coordinators that there's a
Yeah,
holiday.
we have got around
Got
nine
around
seven or 9:8.
9:20 and 9:09
Uh,
we got a
uh,
mail saying that this is the link for today's session, and at 9:15 we got a mail that there's a holiday.
I didn't even get that email, Shilpa. Like that holiday announcement mail itself, I've got it very late actually. I was literally on half sleep and waiting. But
There might be a confusion also. I think they sent an email like 4 days back also. I'm not sure whether it was sent to the learners. But for us, we also received an email like a few days back saying that Janmashtami is probably going to be a holiday.
okay, we
We did not
haven't.
receive any
Yeah,
such.
we haven't got any email actually.
Oh, okay. Uh,
Yeah, I
what can I
think
what can I say? All right, let's wait for maybe 2-3 minutes, and then we'll start. Let's see if others join in, or shall I start? What do you recommend?
Let's wait for a few minutes because they were also finding the issues, right?
Yeah, I think probably there has been some procrastination, or maybe there is a miscommunication.
Have you informed anybody about it, Sanatan?
Like the link about today.
Yeah.
Yeah, I just wrote this DS Scooby account was there, right? She just left.
Yeah.
So I wrote to Charissa saying that maybe the learners have not received the link. Could you forward it?
Yeah, I think now I'm getting a message from Athira from LinkedIn. I didn't know, like when I friended her, she was asking like, have you got a link? I'm trying to send the link to LinkedIn.
Okay.
Let me try to send this link to her. And about NLP, Santan, like we were actually learning the basics about NLP right now, right? There is a lot of.
Correct.
Yeah, okay.
Applications are about to come. Yeah, we will see some applications soon.
Okay.
We have done, I think, one of them, basic sentiment classification. I will show you how you can actually improve upon those with the help of these tools. Okay, I'll start. Okay, it's already 9:15. Or do you want me to wait for, say, 2 more minutes?
I think we good.
Okay, let's go ahead, okay, without wasting any more time. Okay, so what I've done is I've just imported the basic libraries and a basic book that we have seen also in the last class. So this is the Moby Dick novel, which is present in this set of NLTK books. There are, I think, 8 books overall. You can use any of them. I'm using the same book that we used in the last class. Now, typically, you see, like when we talk about creating features, right, or engineering features. So what do you think are the features in a text? So let's keep it interactive. What have we used as our features so far? So in a given piece of text, what do we use as our features?
Those
Can
Words,
you repeat
right?
your question?
Yeah. So the question is, like, in a piece of text, when I want to convert it to numbers, what do I use as features? It is typically words, right?
Yes.
So I say, okay, word 1 becomes my first feature, word 2 becomes my next, and so on. So let's say if my vocabulary has, say, D features, so I have a total of these D features, right? Does that make sense? Or K features?
Yes.
Okay. And what do I put in the values? Like, let's say I have this first document, okay, and this document, I want to represent it in terms of these words. What values I can put it here for these words?
Is it found?
So one
Not
is
like
like presence or absence. Yeah, the word is
Yes.
present or the
Yes.
word is present or not. So we can put the presence as 1 and the absence
And
as
absence
0.
as 0.
Okay, and we
Else
can
we can
use count
count.
frequency. Yeah, the
Yeah.
count. Okay. So you can put the count of the word. This is called as term frequency or word frequency.
Yes.
And we have used one more, which is called as TF-IDF, term frequency, inverse document frequency, right? We have discussed all these three things.
Yes. Yeah.
Okay. So we are going to discuss more about how to engineer more features. So we are going to see what more features can be engineered. Do you think that we can form pair of words? Does it make sense? Yes or no? We can use a pair of words as features. So
Pair
let's
of
say
words.
maybe say a good mobile. Does it make sense?
Yes.
Okay. All right. Okay. So why not triplets? Why not quadruplets? I mean, I can create any size, right? It cannot be
Yes.
just one feature, right? If you think about it. So there is a terminology called as n-grams. Okay. N denotes the size. Okay. So 1 gram is basically a word of size 1. Okay. Basically individual words. So 1 gram means individual words. 2 grams, it means pair of words. Okay. A 2 gram is nothing but a pair of words.
Pair of words.
3 gram would be, so instead of calling it as pair, you can use consecutive words. Does that make sense?
Consecutive. Okay.
Okay. Similarly, 3 gram would be a triplet.
Triplet.
This is a consecutive sequence of 3 words and so on.
4 is a quadruplet.
Okay. Now, do you think we need to go beyond 4? That's a question.
No.
Or maybe sometimes 3 is enough, or maybe sometimes 2 is enough.
Yes.
That makes sense, right? So domain expertise is something that will help us decide, okay, up to what point we shall go. All right. So I'm going to show you how you can choose pairs of words or say triplets of words, and how do you decide, okay, which are good features. So most of the times you will use individual words, 1 grams, but you can also use like 2 grams, 3 grams, and so on. Okay, let's see how do we make these say 2 grams, 3 grams, and so on. Okay, so from NLTK.
But when it comes to industry, like they'll use which n-gram?
That I'll talk about.
Okay. Okay. Okay.
This is the start. This is the start.
Okay. Got it.
The start. See, industry nowadays works on deep learning models. So they work on something called as subword representations. Since the neural networks are not there in your syllabus, okay, we if you really want to dive deeper into it, maybe you can explore subword representations. Okay.
Okay.
Maybe just give it a go. Okay, subword representations. So you can break a word and then make a representation out of it. Okay, to get at a more deeper semantic level. Okay.
Okay.
But for now, let's say I would say all the applications that we are building using traditional machine learning models, they use these n-grams.
Okay.
Okay, I'll show you some advanced modelings as well. Don't worry.
Okay.
All right, let's start with how do we build these collections. Okay, how do we build these collections? Pair of words, triplet of words. How do we decide, okay, which 3 consecutive words should be chosen? So I'm going to use this text one. Okay, this was the Moby Dick novel. These are all the tokens, the individual words in the book. So do you think that I can use it like this? So let's say so let's say I want to generate pairs of tokens. So can I say that for I in say text1.tokens, I can, or maybe I'll do it like this. Range of len of text1.tokens. Essentially, len of text1 would be the number of words, right?
Yes.
Okay. I'm running it up from -1. Okay, I'm running it from -1. Why? Because I'm going to take pair of words. So can I say that the pair of words would be text of one dot tokens of I and I plus one? Yes or no? Does this make sense? So I'm essentially printing each consecutive pair. Does it make sense?
Yeah.
Okay. So I'll actually make it so. See, if length is, say, think about this. Let's say if length of a sentence is 5, it has 5 words. So your array index, okay, it will go from 0, 1, 2, 3, 4. Does that make sense?
Yes.
So when you go to
Yes.
4, okay, so this is 4, right? 5 minus 1, 4. Does range include 4? No, it doesn't, right? So range will go up to 3. Does that make sense or not? See, the reason I'm asking is why have I made it minus 1?
Okay.
If I make it, say, without this, what will happen? Do you think that for the last value, it will have a pair?
No, out of
Right. The last value, so if our sentence has, say, 5 words, okay, when you
Yes.
reach this location 4, will there be at something at 5? No, right?
No.
Because index is 1 less than the range, right?
Yes.
So that's why I subtracted a 1 from it. Okay. So let's print all of them just to show you. Okay. So this is the first token. This is the second token. This is third. This is fourth, and so on. Okay. What do you think can form relevant features? Think about this. What do you think can form relevant features? Any guesses? What do you think can form relevant features? Like you are looking at now pairs of words. I'll put a comma also, okay, and just to show you. Okay. So what do you think can form relevant features?
Adjective and a noun.
Adjective followed by a noun. Okay, that makes sense. So basically, you are utilizing the part of speech to create a pair of words, right?
Yes.
Okay. So let's do that. Okay. So what I'm going to do is I'm going to find the parts of speech. So to find the part of speech, you have to import this POS tag. Does that make sense? This is the POS tagger.
Yep.
Okay. So POS tag, it works on tokens. Okay. It works on tokens. So I'm going to, and you need to give it a string. Okay. Sorry, you need to give it a tokenized string, like individual words. So if you pass it one word, let me just show you. Let's say if I just pass it this one word, okay, and I get the POS tag from it, what do you think this will print? What do you think this will print?
The word and the
Whether
part of
it's a
speech
noun
which is
or a-
yes, where it is belong in the parts of speech.
Okay, so I'm going to say print the first 10 pairs. Okay, I'm going to print the first 10 pairs. See this. So first I'm printing. So it will actually break your individual word into individual letters. See this. Do you see this? See, what was the first pair? Do you remember? It was this exclamation, this square brackets and Modi, right? Yes or no?
Yes. Yes.
See, can you see that it has been broken down into individual letters? Because it
Yeah.
expects a list of tokens. Okay. Currently, you are passing this one token, so pass it as a list. Okay. Does it make sense? You have to pass it as a list. Do you see that now?
Yes.
Yes.
We are passing the list of tokens. It expects a list of tokens. All right. So now that we have our POS tag, okay, which is present in this NN. So you are saying that let me get the POS tag, okay, of this, okay, and if the POS tag, what would be the first character for this POS tag? So let's say I print a 0 here. What do you think this will print? This will print this. No, this will print this. Do you see that it prints a list?
Yes.
So it will print this square brackets and NN. Sorry, just a second. Let me print this first. Just to show you, I'm going to print this. Okay. Do you see that now the list has been removed? Okay. And now if I want to print NN, what should I do? I should print a 1 here, right? Does this make sense?
Yes.
Okay. So I'm going to say that if the first thing is an adjective, do you remember adjective starts with what? It starts with a J, right? Yes or no? So currently
Yes.
it starts with a J. I'm printing the very first letter. Okay, I'm printing the very first letter. Do you see that it's printing the very first letter N, 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 I, C, N, N?
Yes.
So no. I can compare it to the J. So if this is a J, okay, and the next one is a noun, do you think that makes a valid pair? It's a good pair, right? Adjective followed by a noun.
Yeah.
Okay. So here I will say I plus 1. Okay, and rest everything remains the same. So let me get all of those. So I'm printing. Shall I print the tags as well, or shall I just print the words?
Just the words.
Just the words? Okay. So currently in this list, there is nothing. Okay, currently in this list, there is nothing. So I'm going to, so because I'm choosing 10 words, right? So I'm going to go with the entire list. Let's see what are all there. Okay. Okay, so these are all the ones. Okay. These are all the ones. You can see that some of them are dots, square brackets. Okay, but some of them make sense, right? Poor devil, maybe
Yes.
great whales, great fish, strong sword. Okay, so you can use it. Okay, everything else comes to mind that can make a good feature. Do you think a feature should be repeated, say, in a lot of documents? Yes or no?
Yes.
That only then it will. I'm saying when I say a lot, I don't necessarily mean in everyone. Okay, but it has to be present in like you can say 10% or 20% at least, right? So do you think frequency matters? It does, right?
Yes.
Okay, so frequency of the tokens also matter. Okay, so I have to see how many times that word is present, right? So I'm going to show you some functions. You don't have to do it like this. Okay, so see, think about you are going to make a triplets. So would you do all these things step by step? No, right? Does that make sense
No.
or not? I mean, so you will make another basically for loop. Sorry, another if clause, and you will add another and condition. Yes or no? Determiner followed by adjective followed by a noun and so on. Okay. So you can do all that and you can get all these triplets. But nowhere I'm including the concept of frequency, right? So you can actually count the frequency. Do you think I can count the frequency by taking a particular pair and just going through the entire text1.tokens again? Yes or no?
To get the frequency, right?
You have to get the frequency.
Yeah, we can.
So essentially what I have to do is I have to print these, so store all these pairs. I take the unique of it, and then I find the frequency of each pair. Yes or no?
Yes.
That is possible, right? You don't have to do all that from scratch. There are functions for it. That is what I'm going to show you. So I'm going to just use some of these functions. Okay, give me a sec. Okay. So first of all, let me show you this unique function, which is called as, yeah, 1 second. This is called as engrams. 1 second. Yeah. Okay. So currently I did this, right? I made my own pairs, I and I plus 1. Yes or no?
Yes.
Okay. So I'm going to show you one of the functions first. Okay, just a second. So from nltk.util, you can import this function called as engrams. Okay. So let's say you want all possible bigrams. Okay. So what you can do is you can say that the size is 2. I want all possible engrams. 1 second. Okay. I'm going to see the usage of it. All right. So my text1.tokens are here. So you have to provide all the tokens. So it will generate. Just push this below so that you don't get confused. Give me a sec. So what this will generate, it's called as a, object. Okay, this will be called, you can say as a dictionary object. Okay, do you see it's a generator object?
Yes.
A generator object essentially is, you can say it's a dictionary. It will be comprised of two terms. Okay, so I'm going to show you how to access this. So you can say these are all your bigrams. So this is essentially I and I plus one, the for loop that I wrote. It is nothing but text I and text I plus one. Okay, so this is this for loop. This for loop of this running from the range, and this text one I and text one I plus one. Essentially, this is it. Okay. So let me just show you what you can do is, so let's say you want all the keys and the, let me call it key and value pairs in this bigrams. Okay, and you just print the key value pairs. Okay, sorry. Just a second. Oh, I'm going to access it like this. Just give me a sec. So it will give me an iterator object. Okay. Let me see if I can access it using items. No, just a second. Just a second. Okay, I can directly access it like this. So it will directly give you these pairs. Okay, it will directly give you these pairs. Okay, what's the problem? I did done it right. Okay. Yeah, do you see that? So it gives you all possible bigrams. Is this clear? So this is essentially the loop that I was running, I and I plus one. This is nothing but equivalent to this. For I in range, the previous thing that I ran.
Yeah, the text. Got it.
Yeah, this text one I and text one I plus one, it's storing it as a tuple. Okay, it's storing it as a tuple. Okay, this I and I plus one are stored as a tuple. Now, let's say if you want to apply these conditions, okay, can we do that? It's the same thing, right? Yes or no? Okay, let's see this. If I ask you, what should be, say, I of 0, what would you say?
The bracket and a Mobi
The
will be there.
Just
First,
click the bracket.
Bracket.
And if I say
First
what is
element of
one element of everything, right? So can I say that this will now print the individual elements,
yes.
this and Mobi and all that? Okay. Oh, sorry. Oh, why it is so slow? 1 second. This is running, but it's not printing anything. What's the problem? Here, just a second. No. Do you see that now it's printing the individual elements? Can I repeat the same process? I can find the POS tag and I compare it with I0 and I1 tag. Yes or no?
Yes.
It's the same way that I was doing, right? I just have to pass this I0 here and I1 here. Yes or no? I'll do this, okay? Just so that you can see. Yeah. The same thing that I had done, you can use it here also. So you in this text1.tokens, you have to pass this I0. Okay, and here you have to pass I1. Rest everything else will remain the same. Okay, and then we are printing these letters if they are J and N. Okay. What's the problem? There is a problem with my Jupyter notebook. Okay, it's not printing. Does anyone realize what's the problem? Yeah, so it prints everything. Is this clear?
Yes.
Okay, all right. So similarly, let's say if you want to use the trigrams, all you have to do is, I mean, you can
Token.
essentially
Yes.
see this, okay?
Three.
So pass these 3 tokens, okay? So this is just the same for loop that is running, okay? And we are comparing this with D is the determiner, J is an adjective, and this is a noun, okay? Determiner followed by adjective followed by a noun, okay?
Is it the above for loop is still running?
Yes, above for loop is probably still running because the list is huge, right?
Okay.
20,000 words. Okay, I'll
Okay.
just stop it. Does it make sense?
Yes, yes.
So same thing, one second, problem here. This is text one.
Tokens.
Okay, so it prints all the, you can say, triplets for you. Does it make sense? Is this clear? So now you have all the triplets that follow a special sequence of or ordering of your POS tags. So you can do it for quadruplets as well. Okay, you can do it for quadruplets as well. Is this clear?
Yes, Anton.
All right. Now the thing is, see, currently we are not using the frequency of any special. I mean, let's say if I want to use this, the Indian C, this has to be frequent, right? What if it is only coming once? Then it's not a good feature, right? So I'm going to show you there is a function that NLTK provides which considers both the things. Okay, which considers both the things. And you can actually do one more filtering on top of it. So let's say you are looking at this Indian C. Can I say that this Indian C will become even more informative, even for other text data sets? If it is present, say, in a lot of text documents across the world, or maybe say across Wikipedia. Yes or no?
Can you ask your questions?
Okay, so I'll just repeat this. See, the Indian C. Okay, I want to know whether if it's a good feature or not. See, for a given data set, I can use two things, right? It follows a specific pattern of these POS tags, the specific
Yes.
ordering, and also it is repeated a significant number of times. Does it make sense?
Yes.
Now, don't you think I can put even one more filter on top of it? And that is saying that if you look at this Indian C, if this feature is also present in other data sets, then I can say it's a good feature.
Yes.
Okay, so then I can say it's a good generic feature across all, right? Yes or no?
Yes.
It is likely to come in my test documents as well when I deploy the model. Does that make sense? So
Yes.
so you can do three filterings. So one is like follow a special ordering, do a frequency count, and then you make one more check whether this feature comes across other data sets also. Okay, so there are functions for it that you can directly use. So we will see how to use those functions. Okay, just a second, I'll just get to those functions. Give me a sec. Okay, all right, I'll directly go to that function. Okay, here it is. Okay. So I'll start with bigrams. Okay, I'll start with bigrams. I'll explain what these functions are doing. Just wait for a second. Yeah. Give me a sec. Okay, so before I explain this, I want to show you something. See, I talked about the frequency aspect, right? Yes or no?
Yes.
Okay, so how do I know which pair of words is repeated the most? So by the way, there is a name for them. So if you look at your pair of words, consecutive sequence of words, they are called as collocations. Okay, they are called as collocations. So in NLTK text, okay, you can directly access, I think, these collocations. Okay, maybe like this. Okay, or 1 second. Yeah, so these are all the collocations that are occurring the most significant number of times. Okay, the most significant number of times. I think these are how many? 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think the number is 20. Okay, it's printing the top 20 collocations for you. Okay, so this function tells me which pairs of words are repeated the most. So sperm whale is one, Moby Dick is one. The novel is about Moby Dick, right? And then you have white whale, old man. If you have read this novel, maybe you can relate to it. Okay, so these are the most frequent ones. Now, if I ask you, if you look at these collocations, I can put a condition on like adjective followed by a noun. Yes or no? So which ones do you think will satisfy? White whale, right? One of them. Yes or no? Captain Ahab also? Sperm whale also? Okay, in sperm will that become an adjective in that case? Okay. Maybe this cried a hat and so on. Okay.
Old man.
Old man. Do you see that? Okay, one thing that I want to show you is this. Look at this white whale and this small white whale. So it is case sensitive, right?
Yes.
So I'm going to show you how to use these collocations. So first, let me show you a function which can count the frequency of every word. Okay. So there is this function here which can count the frequency of every word. Okay. Yeah, here it is. So this function can count the frequency of every word. The name itself should tell you bigram collocation finder. It is trying to find all the bigram collocations. Okay. And then you look at, so you are importing some of the functions from it. So from your tokens, let's say this is your text1.tokens. Okay. From your tokens, it is going to find all the possible bigrams. And for each possible bigram, it is going to show you what we say is the frequency. Okay. So this is ready. So I can say that for J in Finder, so Finder would be a dictionary. Okay. So a dictionary stores what? Dictionary stores what? Key value pairs, right?
Yes.
And how do you access dictionary items?
Name of the dictionary and square bracket key.
And the square bracket key, right? Okay. But let's say I want to access only all the individual items, the pairs.
Dot values.
No, dot values will tell you the values, right?
Item
value.
keys.
Dot find like dictionary name dot.
This is a dictionary name Finder. Okay. I want to find all the key value pairs. I want to find all the key value pairs. Have you used this items before?
No.
No? Okay. I think you can access it using these items also. Really, have you, I mean, have you not tried this?
No.
No.
Okay. So in dictionary, I think you can access these individual. See, typically what we write it like this, right? We say that, okay, if something is a dictionary, we say, give me all the key value pairs in this Finder. If Finder was my dictionary, I can print the key value pairs, right? Yes or no?
Yes.
Yeah.
Okay. So, and then you can print the key value pairs, right? The NLTK, this Finder object is a little different. Okay. The NLTK Finder object is a little different. What you have to do is you have to, I think you have to access it with this ngram underscore ft dot items. Okay. So it essentially prints, it's a dictionary only. It's a dictionary only. So you will see that it is going to give you key value pairs. So we are printing the key value pairs, but since it's storing like the individual ngrams, okay. So it will give you, okay. Currently we are doing this Finder as bigram, right? So it will give you the pairs and the corresponding frequency next to it. Let's see this. So this square bracket on Moby is repeated one time. Moby Dick is repeated 83 times. Dick by is repeated one time. By Herman is repeated one time, and so on. Is this clear? So now I found the frequency for this. Yes, people. Is this clear?
Yes.
So this is like the second step. So like first you can actually do I mean, what I should say is find all those pairs which follow a special ordering. Then you can look at the frequency. So this is the frequency step. And then I'll show you how to combine them also. Just wait for some time. Now, let's say I want to put a filter on this. Only show me those pairs. Okay. Only show me those pairs which have a specific frequency, let's say greater than 5 or greater than 6. So for that also there is a function. I think the function is called as this. Okay. For that also there is a function. So I'll just put it here. Okay, so you apply this frequency filter, and let's say I want to have only those pairs where your frequency has to be greater than 4. So I'm just going to put a frequency item as 10, and so it will print only those which is greater than 10. Does it make sense? Yes, does it make sense? So if I do K of 0, yes, go on.
This filter and in brackets 10, that means like greater than 10 only.
Greater than 10.
Okay.
Greater than 10. Does it make sense?
Yes.
So now let's say if I want to repeat the same process as I did earlier. So once I have applied this filter count, let's say, what if I do just K of 0? What do you think this will print? Anybody? K of 0 will be what? Mobi. The first letters, right? Dot, by, to, and so on. Does it make sense?
Yes.
Okay, and what would be K of 1? The next one. And don't you think now you have the individual access to the words? You can do the mapping of this nouns and adjectives that we have done earlier here. Yes or no?
Yes.
So I am doing this, right? I can just take this if, okay. So first I applied some filter, okay. First I applied some filter, and now I'm doing this. I'm saying that, okay, give me, so here I'm going to pass K of 0 and K of 1. Does it make sense? So give me only those pairs whose frequency is greater than this, okay, whose frequency is greater than this. And then what we are going to do is we are going to print only the K and maybe say the value as well. Does it make sense? So I'm printing all those. So this is like having two conditions, right? First the filter, which is 10. And then you are doing this like, okay, give me only those pairs which follow this special sequence adjective followed by a noun. Does it make sense?
Yes.
Okay, so this is what you get. And do you see that? I mean, it makes more sense. Yes or no?
Yes.
So these are only those words that we are using. All right. Now I'm going to show you like one step even beyond. Okay, one step even beyond. So if you want to do one step even beyond, you can use this. So the idea is, see, the idea is you applied this frequency filter, right, which is greater than 10. There is one more filtering that you can apply, which I mentioned that this has to occur a lot in a lot of other corpus, right? Yes or no?
Yep.
So what you can think is like using the Wikipedia corpus, okay? Using the Wikipedia corpus, what we are doing is we are checking if the words same and time, if they occur together in a, in the Wikipedia corpus or not. So essentially what this MDust is doing, it is checking which of these pairs, okay, which of these pairs is going to be coming. So I'm actually printing only the top 5 pairs, okay? I'm only printing the top 5 pairs. Please see all the conditions one by one. The frequency has to be greater than 10. Does it make sense? Yes or no? The frequency has to be
Yes.
greater than 10. It has to follow a special ordering, okay? I'm going to show you the third condition. The third condition is look at all possible pairs, okay? You give me only those possible pairs which are repeated more in a lot of other documents, okay? In a lot of other documents, okay? So this PMI measure, it's called as point-wise mutual information. This is called as point-wise mutual information. What this measures is how many times 2 consecutive pairs of words they occur together. Okay, so this is like the third filter that you are applying. Okay, currently note that I am not applying this. So this is like saying I am not using this and I'm simply doing this. Okay, so this is printing for all of them. For all these, I'm looking at give me the top 5. Okay, give me the top 5, and they should be the ones who should be occurring a lot of times in the Wikipedia corpus. Okay, one second, I haven't used it. This is, what did I call it? I have to define this. Okay, just a second. I have to use this. Okay, give me a sec. Okay, so these are the words. Okay, these are the words which in the Wikipedia corpus are according to, you can say, this. In other data sets, these words are seen the most. See, I'm not saying this is actually utilizing the frequency right now. So first of all, please note that are we passing the finder anywhere? Yeah. So this finder only has a condition that these are greater than 10. The frequency of this is greater than 10. Okay, this is the
Yes.
first condition that you're applying. I'm not applying this condition right now. Okay, I'm not applying this condition right now. I'm saying that give me all possible 5 pairs which are repeated more in other data sets. And this is giving me these 5 pairs. If you increase this number, it will give me these 10 pairs. Now, do you think that if if I'm printing all these pairs, don't you think you can run a for loop on it and get this thing and this thing separate? Yes or no? Does that make
Yes.
sense or not? Okay. And then you can apply this filtering with J and N. Does that make sense or not? Okay, like this. Okay, see this carefully. See, it's the same thing that we are running, but we are running it like one step at a time. Okay, let's see this. So I'll say, okay, give me these top 10. Okay, give me these top 10. You already have a condition on. See, please note that you have already put a condition on this greater than 10. So this condition is still, okay, this condition is still ready. Okay, this condition is still working. Now I'm going to say that, okay, if I print I, what do you see? You see them at like separate to separate, right? Each individual pair is separate. So if I do I of 0, what will this print? If I do I of 1, what will this print?
Each of the words separately.
Each of the words separately. And don't you think that I can actually put a condition now this, which I had here? Yes or no?
Yeah.
So this has 3 conditions now, right? This has 3 conditions now. So here it would be just I of 0 and I of 1. Okay, and I will just print I here just to show you only those pairs which satisfy this condition. Okay, so that is just lower job. Is this clear? So you have now put 3 conditions. First, the filtering. Then you are looking at the ordering also, and then you are looking at, okay, from the top 10 pairs which are repeated more across all data sets. Okay, so this should be the only one. You can actually increase this number. Look at maybe the top 20. In the top 20 also, this is the only one. Maybe say, look at the top 50. This is the only one. So this only makes the relevant feature. Okay, this only makes the relevant feature for you. Is this clear?
Yes.
Okay. Now, if you want to do 2 of these things together, like first apply frequency and then, look at the top 5, you can use it. This is just one thing given to you directly. So one second, this will be text1 tokens here. Okay, so just put these, say, some frequency. I'm going with 10. Okay, printing the top 5. So it's printing those top 5. Okay. So currently I've just put everything together, but there is no, what we say is this thing. Okay, so if you want this, just cut paste it and put it here. Does it make sense? And this now prints only the lower chart. So now I've merged everything together. So this is like combining everything. Okay, combining everything. So first, the condition is on frequency. Condition 1 is on frequency. Condition 2 is on essentially your, I would say PMI, pointwise mutual information. Basically the occurrence in other data sets, and condition 3 is the ordering. Does this make sense? Like you have all the 3 conditions being applied in one place. Is this clear?
Yeah.
Okay. You can extrapolate it to even trigrams also. You don't have to change anything. Just change by to try. Okay. Here you just need to change by to try. Okay. So I'm just giving it a name as trigram measures. The function name is trigram. Okay.
Trigram collector.
Going to find, yeah, trigrams. Okay. Now, what are the 3 things that you want to find? Like now you have 3 things, right?
Determinant, noun, and
Okay. Determiner followed by this. Okay. Just a second. So this would be I0, this would be I of 1, and this would be I of 2. So it will print only those triplets, okay, whose frequency is say greater than 10. I'm going to reduce this frequency, maybe some no triplet has greater than, okay, maybe say 5, okay.
First one should be D, not G.
Oh, sorry.
Yeah, the determiner.
That's a determiner. Okay. Once there's an issue anywhere.
If condition.
Okay, this is okay. I think I missed a bracket. Okay, let me see. Is the closing bracket there? No, the closing bracket also needs to be there. Just a second. It's not matching with anything, right? This is matching with this. Okay. This is all right. Yeah, I think we need to put one more
The
bracket
bracket only, yes.
at the end. Yeah, it's fine now. Okay, so it's running. So it prints nothing. Essentially, there is no such feature which has D, J, and N. Okay. Let me put, say, frequency as 2. Okay. And I'm going to print, say, the top 100. Okay. Or maybe the frequency is 5, but printing the top 100. Okay. Is there anyone? No, still not. Let's reduce the frequency. Still none. Okay. Just a second. Shall I do it without this? Okay. Shall I do it without this condition? Let's print all these. Okay, these are all these. Maybe say there is nothing in this. Okay, there is nothing in this which satisfies this condition. Yeah, there is nothing in this which satisfies this condition. D followed by adjective followed by your noun. Okay, in this case, there is none. Okay. All right, let me just see. Okay, if no, I'm looking at 100 top most popular. Let me say, give me the 1000 most popular, and frequency is say 2, at least 2. Okay, just a second. I can pass this here. I was doing it for the top. Okay. Yeah, it prints everything now, so that's fine. I think we'll find at least one now. Hopefully. Yeah, there are some. There are some. Okay, so an empty while the Persian girls and so on. Okay, is this thing clear?
Yes.
Okay, so you can use some of these features. So now they have a special ordering. You have a frequency filter on top of it, and they are using PMI to look at their respective occurrences in the wiki corpus. Okay, so this is how you can create your features. I'm going to show you some advanced, you can say, like EDA techniques using NLTK. So one of the things that you could do is sometimes you may want to see the frequency of each element, right? Yes or no? Like one of the things which is important is like we would want to know what is the frequency of each element in the list of tokens. So these are my tokens, right? I want to know how many times each token is repeated. Okay, so there is this thing called as frequency distribution that you can plot also. It's a function that you have. Yes, there are several things that you could do with this NLTK package. Just give me a sec. Yeah, here it is. So using these text1.tokens, I'm finding the frequency distribution. So it's telling me that comma repeats the most, then the, then off, and so on. Okay. So let's say from this distribution, you want to plot, say the most common words. So the attribute is most common. I want, say, the most common 5 of them. So these are the top 5. Okay. These are the top 5. If you want to plot essentially say these top 5, okay, in a plot. So I think it's called as a frequency distribution plot, something like this. Yeah, here it is. So using this frequency distribution, you can plot it. You are doing it for the top 10. Let me do it for the top 5. Okay. So these are the top 5 words, comma, the, dot, of, and. Okay. So these are the top 5 words. If you want, you can remove stop words and then repeat this process. Do you want me to do that? Shall I remove the stop words? Should I remove the stop words from your text one tokens list and then I find out
Yes.
which words are okay?
Yeah.
Let's see this. Okay.
We have done something in the previous things,
Yeah,
right? If you
It's
copy
easy.
paste.
Yeah, what you have to
Yeah.
do is first you get the stop words
Stop
list from the
words.
corpus. Okay, and let's instantiate these stop words list. Say stop words dot words. I'm only looking at English stop words. Okay, so this would give you your English list of stop words. I'm saving it in say SW. And now you can extend this list because there are special characters, right? So I'm going to extend it with a dot, exclamation, comma. What were the top few? Can you see? A would be removed. Okay, so I'm just going to keep maybe say some question marks. Okay, let's just extend this. And now I have to say, okay, so since I've already extended it, okay, so I'll say that, okay, for I in say text1 dot tokens. Okay, I'm going to use my data as a data here, data without stop words. And I'll say that, okay, data without. So if I not in stop words, you can append this data without stop words with I. Does it make sense? So currently I'm checking if each word, for each word, if this is not in stop words, just make another list, data without stop words, and just put it there. Okay. So here you can pass this data without stop words. Okay. So this is data without stop words. Okay. And so there are special other characters also. So let me just append this here. Semicolon is there. Then you have this quotes. What else is there? Hyphen is there. So obviously it makes sense. Okay, these words would be repeated quite a lot of times. Then you have double hyphen. Anything else that you see? This is enough, right? Just to show you. Okay. I would have done this lower. Okay. For I, okay, if I dot lower, not in stop words. Okay. Okay, do you see? Now there is a dot also. I have added dot already. Oh, this is dot and this. Anything else? I think this is more than sufficient just to do this. Okay. So let's see. These are the most common ones, and let's plot the top 10, maybe say, just to see. Okay, so these are the top 10 ones. There is still a symbol which has not been removed. Comma has not been removed. Oh, I have removed already. Oh, I'm plotting from text one. My bad. I'm plotting from text one. Now you will see all the words. Is this clear? Yes, people. Is this clear? Any questions up to this point? Okay. I'm going to show you maybe a few other things. So imagine that you have a book, right? And now you want to see, okay, where a specific word is used. Okay, where a specific word is used. So this is your book, say text one. Okay, it's a NLTK textbook. I want to see a specific word being used. Okay, so that is called as concordance. Okay, so give me a word. I'm going to show you in that specific book where this word comes. So you can actually peek into the book and see like where this specific word is coming and in what context this word is used frequently. So give me a word.
Whale.
Okay, let's go with whale. Okay, so do you see that whale is kept in the center? And it is telling you in the book where this word whale is used. So you can actually see the context of this. So this gives you an idea, okay, whether whale can be a good feature or whale will be a bad feature. Does it make sense?
Sure, Santan.
So this is like, I mean, a quick search, okay, in a NLTK textbook. Okay? Just to peek into the book and figure out, okay, if this word is important or not. Okay. Now this is doing for one, right? This is doing for one. I'm going to show you a
Oh, yeah.
I'm going to show you a plot where you can actually see, okay, how many times a word is used, okay, and it will not tell you how many times, but it will actually show you. So I'll show you maybe a plot, the plot first, and then we will discuss it. Okay, just give me a sec. This is called as a dispersion plot.
Just now I got a call from the GUI people and they were now sending me a link. Okay, you need to join this link.
It's okay. It's okay.
I was literally screamed at them like, this is not happening for the one reason. I'm just dropping an email to you guys. Like, I didn't know why I'm paying this like that. I was literally got furious.
That's okay. That's okay. It's okay. Don't. I mean, it happens with everyone, right? So this dispersion plot is a nice way to visualize where these words are used. Okay, where these words are used in a book. So imagine that I'll give you this word Moby, because the book is about Moby Dick. So I want to see where all Moby word is used in this book. So it will show you a nice plot. Look at this. So do you see these vertical blue lines
Yes.
corresponding to this word Moby? So it is telling you at these locations the word Moby is used. On the x-axis, you can think of it as index 0, index 1, index 2. So there are more than 260,000. If you remember correctly, then I think the number of tokens in this is around 269,000. So 260,000. Okay. So if at the first index this Moby was used, you will see a black, I mean, this vertical blue line here. So can you see that whale is repeated quite frequently?
Yes.
Okay, so it is giving you an idea that whale is, so this book is actually about this, maybe the story of a whale. So maybe this book is about the sea. That's why you see it over there. Okay, and if this is actually telling you, sometimes it gives you an intuition of like where a particular word is used. Okay, how many times it is used. So the more vertical lines that you see, the more number of times that word has been used. So if you look at this whale, right, how many times this was used, we figured it out, right? 1,226 times. Okay. All right, in total.
And what this Moby Dick book was all about, so that will.
This is an adventure about the sea.
Okay.
Yeah.
So that's what the whale. Okay.
Yeah. Okay. So is anyone a Christian here? So maybe I can do it on the Bible. There is a Bible book also here. So maybe you can talk about it, because I have no clue. I haven't read the Bible, so I have no clue.
Okay.
Okay. Let's see if there is. Okay. Any other thing which I'm missing? So these functions are important. They can help expedite your journey in determining the important features. Okay. 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 Let's see our first application now. We are going to see our first application. This is called as named entity recognition. So the idea is, if I give you a piece of text, which parts of the text do you think are the most important? Like if I ask you, what is this text about? What is it that you would do to figure out, okay, what is this text about? Any guesses? So given a piece of text, let's say I write that, okay, I'm going to give you a sentence. Maybe say this is the sentence. Say
Find out the noun.
nouns, right? That is one way to do it. Okay. So let's say I'm writing this, okay. Like this. Okay, maybe say I used to work in Amazon in around 2018. Okay. Say in Bengaluru, India. So if I ask you, what is like the important bits? So what is it that you would recognize? Maybe Sanatan,
Jonathan, Amazon,
okay, Bangalore,
2018, Bangalore.
India, 2018. Okay. So there is this nice package in which is called as any_chunk. Okay, this is a function which is available to you, which can give you a tree-like structure. So it can break a given bit of a paragraph or a given bit of a sentence into a tree-like structure, and it uses the POS tags returned by the WordNet. So we have used these POS tags, right? So if I pass the POS tag for this sentence, I'll use the word tokenize function also. From NLTK, import this word tokenize. Okay. So if I just print this word tokenize and pass it on to the sentence, what do you think this will print? We have seen this before, by the way.
It will give a token to the each and every word.
Individual
Word
token, right? It takes Sanatan used to at like
Yes.
individual. Okay. Now let's see this. Okay. If I do the POS tag of this, what do you think this will get? If I
You'll
do
get the parts of speech like
you'll
for
get the
this.
speech for each, right? Okay.
Yeah.
Makes sense? Okay. Now you can pass this to this any_chunk, and it creates a nice tree for you to visualize. Okay. It creates a nice tree for you to visualize. See, I can extract the nouns from here, right? Yes or no?
Yeah.
Yes.
I can extract the nouns from here, and my job would be done. Okay. But this any_chunk gives you extra information also. Okay, let's see. So I'm just going to import that function. Okay, give me a sec. Okay. So this was my input text. Okay, so what we are going to do is we are going to import this any_chunk. I've already imported word tokenize. Okay, PLT I've already imported. So if you want to draw this tree separately, okay, you have to install this library tkinter. So install this library using this sudo apt-get if you are using Linux, or you can simply install it via pip. So saying pip install this package name. Okay. So it will open up a window, a special window for you, and there you will see. So it would be like, it will not be plotting the tree inside, it will be plotting a tree outside if you want to plot it outside. Okay. And we need to have this function draw trees, okay, outside. So we have already gotten the tags. Okay. So let's see this. So this is my tokenized data with the tags. So pass this here. Okay. So it will print the nice tree for you. Okay. And it doesn't look nice, right? As of now, this is text. Yes or no?
Yes.
Yes.
Now I'm going to show you if you print it like without. Okay. 1 second. I think it will take some time. You see this? So it gives you this nice tree-like structure. I mean, if you look at the text, okay, S is like the root. Okay, this NE stands for named entities. Okay, so it tells you what are the named entities. Do you see that it recognizes all the named entities nicely?
Yes.
Okay. Even 2018 that you were worried, right? I mean, this is the cardinal number. It's a number, right? So it's recognizing it as a number. And now let's say if I want to see a relationship between two entities, don't you think I can look at this tree and that gives me an idea what is the relationship between them? So let's say you want to figure out what is the relationship between Sanatan and Amazon. Don't you think that you can use it, used to work? Like from a pictorial point of view, okay? And then you can extract this info. Okay. Now, beyond this, I'm going to show you what this offers. So currently we are setting this binary equal to true, right? Just remove this. So by default, binary is false. Okay. And let's see this now. Do you see any changes? See some changes here. Okay. What do you see? What is Amazon right now?
Organization.
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 Okay. So if you want to extract info about like a particular entity, if it's an organization, GP I think stands for general purpose entity. Okay. So it recognizes so I think it's called as let me see, I think it's called a general purpose entity or something, place or something. Yeah, GPE in NLTK. I think it's called as general purpose entity, if I'm not wrong. No, not this. Okay, not this. Geopolitical entity, my bad. So, so this geopolitical entity, okay, so it says that, okay, maybe I am a geopolitical entity. Okay, from the model on which it is trained, the corpus which was used to train this model, there it would have seen Amazon and it recognized this Amazon as an organization. Bangalore is a place. Okay, so it says that, okay, this is a geopolitical entity. India also is a geopolitical entity. Okay, let's see if I pass this sentence instead. Give me a famous person that was there, say, prior to, say, 2015, who's really famous.
2015.
Prior to 2015. Okay, because I'm not sure like when this model was like finally like when this was finally retrained. So I'm assuming, okay, at least 5 to 8 years would have been there. Okay, let's use, say, Bill Gates. Okay, so we are tokenizing it. We're using this chunk. Okay, and these are the entities. Okay, now do you see that, okay, it recognizes this Bill as a person? Not Gates, but Bill as a person. Because Bill is the name of a person, so it recognizes it.
Yes.
Okay. So do you see, look at this, okay. Who is the CEO of Microsoft? I mean, it recognizes this, right?
Yeah.
Okay. So this model can work wonders. I mean, if you want to get like at a deeper level, the understanding of the language. Okay. So maybe you can use this. I'll show you also this draw trees function that we used. Okay. So this will actually draw the tree outside. Okay. And to draw the tree outside. Oh, I think I ran it so many times. Okay. Do you see that? Okay. This is the same tree that we were having, but now we are drawing it outside. Okay. So let's say if you want to show it to some people, right? And I mean, and you want to zoom it in, I think this is a nice way to do it. Okay. This is a nice way to do it. Okay. So this is actually interactive. Tkinter is interactive. You can drag and drop also. Okay. I mean, you can stretch these arms also if you want. Okay. So you can have a nice visual representation.
So this function is working based on the parts of speech, or it has trained on some.
It's trained on the Wikipedia corpus. Okay. Somebody manually sat down and labeled everything. Okay. And then they trained this model. And now it is trying to recognize from the piece of text that you gave, what are the different components in it.
Okay, so but it has some years of limitation to the information that has been fed to it. Right?
So, like, by what time it was trained, right? I don't know that. I don't know that number. Okay.
Okay.
Okay. But this is traditional NLTK. Okay, this is traditional NLTK. You can actually go far. Okay, you can actually go beyond. There might be better tools than this. Okay, there might be better tools in this, but they will be deep learning based. Okay, they'll be deep learning based. Okay, there are definitely tools for this. I would recommend that, okay, you check out this library, spaCy. Maybe I'll show you. Okay, I'll show you maybe today. Or yeah, I think I can show you some of the things from spaCy today itself. Okay. Okay, this is your one of the things that is quite frequently used, especially in translation tasks. okay, especially in translation tasks, to understand what are the entities, what are the relationships, and then you make use of it to do translations better. Okay. Okay, let me do another application, which is sentiment analysis with the help of some tools. Okay, with the help of some tools. So traditionally, what do we do? I mean, we have done this in the like done this before as well, right? Like traditionally, what do we do? I mean, given a data set and the sentiment, what would we do?
See whether it's a positive or a negative or a neutral sentence.
Sentiment, right? Okay. So have we talked about this Vader model yet?
No.
No. Okay. All right. I'll give you this intuition. So NLTK has this model called as Vader. Okay. And what this Vader is nothing but, okay, let me give you a sentence and you tell me, okay, like how does your brain work? Okay, try to interpret it. So let's say a fragile product. Okay, a total waste of time. Okay, total waste of money, let's say. What would you categorize it as?
Negative.
Negative. What are you seeing here? So you are categorizing it as negative?
Take like looking for the adjectives, and those adjectives are whether positive or negative based on that.
Makes sense, right? Okay. So what Vader is a set of, essentially a set of keywords. Okay, it's a set of keywords. So a set of keywords is also called as a lexicon. Okay. So what Vader has is a set of keywords which are positive and negative, essentially which are positive and negative. And every keyword is given a score. Okay. So set of keywords with a score. So if you give a keyword, okay, which is negative, so it will have a negative score. If you give, if you have a positive keyword, it will have a positive score. So the idea is, if I normalize the sum of the keywords, can I say that I can use it as a strategy to figure out essentially what the polarity of the sentiment is for a given sentence?
Yes.
So the idea is, look at all the keywords that are there. Okay, in this, what do you think are the keywords? Fragile,
Fragile.
Waste.
These two only, right?
Yes.
Okay, maybe money is also keyword. I don't know. Okay, I don't know. Okay, but it's a set of limited keywords, I should say. Not every word would be a keyword. Okay, so what it does is, for a given sentence, it tries to identify what are the keywords in it and the score which it has stored. So what do you think are the limitations of this Vader? What do you think are the limitations of this Vader? It is doing this, okay? It is storing a set of limited keywords with a score. Okay, so what do you think the limitation of this approach would be? So every time, so
On those keywords, it will not be able to classify the.
That is one thing, right? It will say that, okay, that is neutral. Yes or no? For any word that it does not recognize, it will say that it's a neutral sentiment, right?
Yes.
The combined score would be 0. Okay, any other limitation that you see? Any other limitation? Think.
There are some sarcastic, suppose comments maybe, and in that it will not be.
Everybody would fail, not just this Vader. There everybody would fail. Okay, sarcasm is actually one of the hardest things to detect. See, because we work with like text, right? It's very difficult to understand the semantics of sarcasm, right? Even humans fail. So it's hard to teach machines, okay, about that. So okay, any other thing?
It has a limited words. Okay.
That we have already discussed. So if the keywords are not there, it will not give the correct meaning.
Detect, yes.
So it will say that it's neutral, but since keywords are not there, it will say everything is a 0. So it will say that, okay, it's a neutral sentiment. The one problem that I see is this. Do you think that a keyword deserves a negative score in, let's say if there is a word like fragile. Okay, maybe say I'll choose another word, say bad. Now bad is also quite negative. Say moderate.
And contextual meaning it will lose.
Not take note of. That's what I'm coming at. So I'm saying that there are keywords, right, which will have different meanings in different contexts.
Yes.
So let's say like moderate. So moderate, you can say, you can consider it to be bad, and you could also consider it to be good, right?
Yep.
Think about it, because it lies somewhere in the middle. But maybe it has seen this word moderate in a positive sense. So it will give a positive score to moderate, right? There will not be two scores. Yes or no? So it does not use the part of speech. It does not use essentially the context of the word. It only uses the keywords directly. So it is not context driven. Okay. And the set of keywords is limited. So do you understand the limitations of it?
Yes. The context.
So
and the-
essentially it is not context driven. Okay. And the second thing is, I mean, limited keywords.
Limited keywords.
Okay, so these are the two limitations of it, but this still this approach is quite popular. You can actually add your own keywords, give a scoring to it. Okay, so that way you can extend it, but it has almost all necessary keywords. Okay, let's see. Okay, just a second. I'll have some applications here. Yeah, it is there here. So VADAR, I think it stands for valence aware. Valence means the frequency aware. Okay, valence aware dictionary for I don't know what E stands for. R stands for reasoning. Okay, sentiment reason. Okay, so where is this E coming from?
I think they were taking it from the sentiment.
No, but here sentiment.
But they've put it as basis instead. Or,
No clue. Okay,
yeah, I'm just looking.
let's see. Let's see. Maybe there is say sometimes, or it chooses like this.
Yeah, that's what.
That's why I was like confused, okay, because I don't remember what does E stand for. Yeah. All right, so this is the full form for VADAR. The idea is it looks at, so you need to download the lexicon for it. So lexicon is nothing but the word and the corresponding score. Okay, so you can download this using this nltk.download. This is the VADAR function, sentiment intensity analyzer. So I am storing this as VADAR because we can relate the two things. Okay. And you can actually use this function called as polarity scores. It's called as polarity scores. And let's say you pass a word, say fragile. Okay. So it says that the word is neutral because fragile is not present. So one of the things that you see, right? This word is not present.
Yes.
Does it make sense? Okay. Give another word, let's say bad. Let's see. Yeah, so let me explain what are these things. So the first three things are probability scores. So the first three things that you see are probability scores. MEG stands for negative probability, NEU stands for neutral, POS stands for positive. And this is the score that it is storing. So BARD has a score of around minus 0.5423. Does it make sense? Is this clear?
Yes. Yes.
So for a particular keyword which is not available, it will say that, okay, it's neutral and that score is 0. Okay. So do you think AND would be a keyword?
And I don't think so.
So it will still say it's a neutral and compound would be a 0. Do you see that?
Okay.
Does it make sense? So you can do, yes, go on.
And you said, can you give the explanation for compound ones?
So compound score is nothing but the score given to a word.
Okay. Okay.
So every word is given a score, right? So only keywords would be given a certain score, right? Positive or negative.
Yes.
So you can see that bad is a keyword which is there in the lexicon. That's why you see it's a negative 0.5423. But and it's not going to be a keyword, right? So that's why I said, okay, compound score would be a 0 and it will be recognized as a neutral text. Okay. Even for fragile, see, fragile, you would say that, okay, it's a negative word, right? Yes or no? But it is
Yes.
not in the corpus of this. Okay. So that's why it says that fragile is a 0. Okay. Otherwise, you would see some compound score for it. Okay, otherwise you would see
But
stop-
as stop word, we can extend the wader also, right? So
Yeah,
that
I mean, so
using that we can.
that's the stop words have a compound score of 0, so they don't impact at all. Okay, stop words have a compound score of 0, so they don't impact at all. Okay. Okay, give me another word which you think would be there in the keywords like good.
Let's check moderate also.
Moderate might be there. Okay, let's see if moderate is there or not. Should be there, I think. No, it's not there. It says that
Neutral.
moderate is also neutral. Okay. Think of highly negative words.
Worst.
Okay, that would be there for sure, I think. Yeah, highly negative.
Yes.
So I think the dictionary is quite limited in that way. If you think about it, you can always extend it, right?
Yes.
Okay, you can always extend it. So let's use this wader and see, okay, what do we get, okay, on the sentence that we had. So let's say wader dot polarity scores. And so I'm going to pass a sentence here. So let's say a fragile product. Okay, total waste of money. So if you see a negative compound score, okay, that means that some of the keywords were negatives. Do you see a negative compound score? Maybe if I look at waste. Okay. So you will also see waste was probably a keyword. Okay. Waste is probably a keyword. Okay. Do you see that? And what do you think the only keyword is, if you think about it? If fragile is not a keyword.
Waste.
Waste, right? And do you see that it also predicts for the same score for this? Yes or no? Does that make sense or not? So what would you label it as a total one? What would you label it as a total one? I mean, think about this. You can do the predictions in two ways, right? Which class is getting the highest polarity, highest probability score? Neutral.
Yeah.
Okay. But is it neutral? No, right?
No.
So there are two ways to do the probability. I recommend that you use the compound score. Okay. I recommend that you use the compound score. So one way to do this is this. See, this looks like a dictionary, right? Yes or no? Curly brackets.
Yes.
Okay. So one way to do prediction is this. Look at this. So I say that there are two ways to do the prediction. See, one is that you get all the probability scores. Okay. So get the negative probability score. This is this much. So I'm going to call it, say, NEG. Okay. Let's say negative prob. Okay. And you get the positive prob. Okay. Just copy paste this. So this
POS
would
at the
be
end.
POS. Okay, and let's say you get the neutral prob. This should be this NEO. Okay, and I'm going to put them all into this list. So negative prob, say neutral prob, and positive prob.
Positive prob.
Okay, let me convert it to an array because that would be easier. Okay, and if I want to find, say, the index of the maximum value, what function do I use? Argmax? Yes or no? So what do you think this will return? What do you think this will return?
Whatever is the maximum, like new score.
No, it will return the index of the maximum value. So in this list, which value is the maximum?
Neutral.
Neutral, right? So it will return what? 1. Negative prob, if negative was the highest, it would return a 0. If this is the highest, it would return a 1. If this is the highest, it would return a 2. Do you see that it returns a 1?
Yes.
Does it make sense? So can I say that if, okay, let's say this is the index. Okay, can I say that if IND is equal to 1, okay, or 0, let's say, what would you say? What is the sentiment? Negative? Yes or no?
Yes.
Else if you say that, okay, index is equal to a 1, we say that it is neutral, which is wrong here, by the way, but still we'll say it's a neutral. Okay. Else you say that, okay, this is a positive. Does this make sense? So it prints a neutral for us because the sentence is like this, right? Yes or no?
Yes.
Okay, let's do the prediction on another example. Okay. So give me a sentence. Give me a sentence for which you want to do the prediction.
Mm.
Okay, let's say dim lights. Okay, let's say dim screen light. Yeah, dim screen light. Okay. However, the features are great. Okay, however, the features are great. Okay. Anything else? Well, what do you think this would be?
Dim screen light. However, the features are great.
It seems to be as a positive thing. Okay, because I don't know whether dim would be a keyword or not. Okay. Light may be a keyword, but it is also used in the context of screen light, right?
Yes.
Okay, so again, I think it will come out to be positive. I don't know. Let's see. It is still neutral. Yeah, still neutral. So let's see. Okay, if some of the keywords are there from here.
So actually, the argmax will give us the maximum value in the array, and then it will return the
Value.
index, right? So based on that index, like if the index is equal to 0, we were considering it as a negative.
Correct. This would be at index 0, right? In this list.
Okay, okay.
Okay, makes sense. So let's see if dim is a negative or a positive word. It's
Neutral.
not recognized. Okay. Let's say light.
Light.
Sorry.
Quotations.
Oops. It's not recognized either. Okay. Great would probably be recognized. It's a positive word.
Positive.
I think, however,
Neutral.
but it says that, okay, the overall compound score boils down to neutral. Okay, overall compound score boils down to neutral for this. Okay. It's a screen,
Neutral.
not a score. Features. Okay. I think only great keyword is there. Okay. So I think it must be normalizing it. Okay. It must be normalizing all the values and then giving you a. So using this, okay, using this, it tends towards neutral. I'm going to show you what you can do. Okay, what you can do. Let me just see the polarity score of this sentence. Okay, let me just print this as well. Print this as well. Okay. See, despite having a high compound score, it still says that, it is more inclined towards neutral. Don't you think that I can use a compound score also for making my prediction? Yes or no? I can use the compound score also to make my prediction. See, we know that for a negative keyword, what is the score? It's a negative score, right? Yes or no? So I will use this, okay? Just see this, okay? So I will put it like this, okay? Let's see this. So let me get these polarity scores. Okay, let me get this polarity scores. Okay, so this is my compound score, by the way. Okay, this is my compound score. Here I should call it just a sentence instead of this. Let's call it compound score. And what I will say that, okay, if compound score is say greater than 0.05, can I say that, okay, it's a positive sentiment? Else if I say that, okay, if compound score is say less than 0.05, okay, I say that it's negative. Does it make sense?
Yes.
Okay. And this will give me like more correct predictions, right? So I advise that, okay, you use this strategy. Okay, so this comes out to be positive. In this case, the sentence was this. Sentence was this. Okay, I will use the fragile one. Okay. So do you see that? Okay, previously it was printing it as neutral, right? But now using a compound score method, it predicts both the things as correctly. Yes or no?
Yes.
Okay, any other thing that you can share for any sentence? So compound score method is better.
Y-
Yeah, give me a sentence that you want to check.
I was disappointed by seeing your score.
Okay. Okay, let's see. So it is negative. Maybe disappointed is.
Yeah.
I'll just print the scores as well, just in case. See, even though it is still inclined towards neutral, but the compound score is negative. Okay. So use the compound score for making your predictions. Okay. We will talk about advanced ways also, but not today, because I have to show you some advanced techniques. Or shall I show you today itself? What do you recommend for sentiment classification?
We'll go as per your plan.
No, I mean, if you think that, okay, because we are doing sentiment classification now, there was
Yeah,
otherwise
then
break.
Uh,
So
one
let me,
question-
yes.
I have one question, like if the compound score is 0.4,
Mhm.
positive 0.4, it will be a positive or a negative one?
If it's 0.4, and my condition is greater than 0.05.
So the value and the sign itself will not tell me whether it's a positive or negative.
You can, but then how would you do
Then
it?
it will be greater than 0 and less than 0. That
You can actually change it, right? I'm not saying that. See, I have just done 0.05 to ensure that I cut some leeway as well. Yes or no? So maybe there are, let's say, equal number of positive and negative keywords, but there are subtle differences in their scores, right? Yes or no?
yes.
So I'm saying that 0.05 is not much, right? If you think about it, you can always tweak this threshold. Yes or no?
So actually, the only thing I'm confused over here is if my score
Oh,
is
I should have
0.01.
put a minus sign here. My bad. I should put a minus sign here. You're right. I should put a minus sign here. I should put a minus sign here. Anything between. So essentially, neutral is between minus 0.05 to 0.05. Okay, I made a subtle mistake here. Yeah. Neutral should be between minus 0.05 and up to 0.05. So you're saying that I can reduce this threshold, right? That's what you're saying.
No, now the sign thing is because here the confusion which was happening was if the score is 0.01, then it will fall under negative, but it is
Negative.
not negative.
I made a mistake. I forgot this negative sign. I forgot this negative sign. I wanted to say that neutral is between minus 0.05 to 0.05. I forgot this negative sign here. Okay. It would still be negative, right? I mean, if you think about it.
yes.
Okay. I'll show you the state-of-the-art model. Okay. I'll show you the state-of-the-art model. So nowadays, like people are using these transformer models. See, I don't recommend it if if you are using it for a project, then well and good. Okay, but if you are asked these things in an interview, right, you can just say that I'm aware of it, but I'm not aware of the intrinsic details, because you can get stuck if they start asking. Okay.
Okay.
Because you have not been taught the architecture of transformer models. You have not been taught like basic like neural networks. See, these things are taught in the ML engineering course, but I'm just showing you for your understanding's sake. Okay, this thing also exists, and this is the best, okay, across the world. Okay, this is like the best model if you want to do sentiment classification. Whatever model that you will come up with, it will probably not beat this. Okay. So I have a recommendation here. So please note that this is a suggestion from my side first. So use this model like when you want to build a real application. I mean, if you just want to present to someone, then don't use it. Otherwise, because it can raise a lot of questions and then you might get stuck. Okay, so it would be a negative point there. Okay, one more suggestion is this transformer model. This is actually a BERT-based transformer model. BERT is a special type of a transformer. This transformer model gives only two sentiments, positive and negative. Okay, positive and negative. And the name of this model is sentiment BERT or SentBERT. The name of this model is SentBERT. Okay, this is the name of the model. Okay, it only gives two sentiments, positive and negative. Okay, it doesn't give neutral. It doesn't give neutral. Okay, keep this in mind. It only gives positive and negative. So let me show you. I might have it here somewhere. Let's see. Just a second. Okay. Give me a sec. So I work for a lot of other organizations. So I'm giving you some more details. This can help. Okay. Just a second. Let's see if I have sentence BERT here. Otherwise, I mean, I'll just, you need to have a good amount of RAM if you want to run this model. Give me a sec. Yeah, here it is. Okay. So just to show you, okay. So I'm just running this model. Okay, first, I mean, getting this model. Let me see. Let's see how you get the predictions. It's actually getting the model. It downloads it from a repository. Okay, so that's why it's taking some time. Just a second. I'll show you an extension to this model also tomorrow. There is one more way in which you can extend it. Okay, this is done. So let's see how do you do the predictions. So I'll just pass this sentence here. Okay, let's say you want to pass a sentence. So this is my sentence. What is my sentence? Let me just print that first. I hope it doesn't disappoint me. Okay. Okay, so you see that, okay, it prints a negative score and the score is quite high. This is the probability score, by the way. This is not that compound score. Okay, this is the probability score. Okay, give me another sentence if you have. Let's say a fragile product. Okay, simply this. Okay, so it's a highly negative score. Okay, think of, okay, try to fool it, maybe do some sarcasm. Okay.
Sarcasm. Suddenly I'm running out of it.
Okay. So see, it doesn't recognize sarcasm, right? I mean, I put a smiley emoji right in front. Okay. So even like the best models, they will fail. Even like the best. But I mean, there is a very little hint of sarcasm here, right? If you think about it.
Yeah, not so good.
Okay. Maybe I'll just add some more emojis. It still says, okay, I mean, probably it's not recognizing the emojis. Okay, anything else? I mean, obviously not so good as negative only. Anything else? So this is like one of the best models that you could use. Okay, this is like one of the best models that you could use. Okay. There is one more variant of it that we'll discuss in the next class. Okay, but I have to teach you something called as embeddings. Okay, there is something called as embeddings. So I'll give you a hint where we are moving right now. See, what is the problem with text processing, especially in the context of generating features? What is the problem with it? Yes, people, what is the problem with it? If you want to generate more features, what do you think is the biggest problem with text processing?
If I generate the features, the sentence gets lost, and when the sentence gets lost, the actual contextual meaning for any word we
Gets lost, right? So one is like that the number of dimensions are huge. Yes or no? So far the representations that we have seen, okay, so far the representations that we have seen, especially these bag of words representations with term frequency, presence, absence, and all that. What are the limitations? So one of the limitations is, as you suggested, okay, the semantics get lost, right? Yes or no? Semantics are lost.
Yes.
The second is the ordering is lost. Yes or no? Can you, so if I give you the word vector, can you generate the original sentence from it? Not possible, right? So vice versa, you cannot go. Okay, so you cannot construct it. Okay, another thing, so another important issue is think of the number of features. Number of features are exceptionally
very large.
okay, very large. Okay, and there is one more issue: sparsity.
Yes.
Okay, most of the features will not be used, right? Yes or no? If you think of a given sentence, how many features a row is utilizing, a text is utilizing? Very few, right?
Yes.
Okay, I mean it's just a few features which have some values, right? Even if you think of TF IDF. Okay, so we will try to tackle these. So essentially the idea is there is something called as an embedding. And what are these embeddings? So embeddings are nothing but low dimensional, okay, low dimensional dense representations, okay, low dimensional dense representations. So that are obtained using a neural network model, okay, using a you can say using a special variant, special neural network variant. Okay, why am I writing a special neural network variant? Because there are so many variants which can generate these embeddings. So I will talk about, okay, which models you can use to generate these embeddings. So embeddings can be made task specific. So these embeddings can be made task specific. So let's say if I give you this text, okay, if I give you this text, maybe say Bill Gates is the CEO of Microsoft, and you convert it into say bag of words with the TF IDF. Your number of features are say 20,000. So it will just have 5-6 values only, right? From this, after eliminating the stop words and all. Our objective is to convert this 20,000 dimensional representation into just a say 100 dimensional representation or a 200 dimensional representation, which is quite dense. Okay, which is quite dense. So we will see embeddings of sentences. You can say paragraphs or documents. We will also see embeddings of words. Okay, we will also see embeddings of words. Okay, and I'll talk about, okay, what type of tasks you can do with it. Okay, and you can figure out what are synonyms, what are homonyms, and all that with those embeddings. Okay, how would you recognize if two words are similar? Can you give me an idea? How would you recognize if two words are similar? Any guesses? Like think of a basic English task. How would you recognize that two words are synonyms? Anyone? It's a basic interview question. They might ask you this as well. How do you recognize? So if I give you two words, you have to tell me whether they are synonyms or not. What would you do?
Lematize and see the base words.
No, not necessary. See, lemma is going to give you. Okay, think about this. Let's say there is a word called as, say, verse. Okay, you know that. Okay, lemma is bad. Okay, I'm going to say that another word is, say. Okay, let's go to the dictionary. Okay, so let's type verse. Okay, let's ask Google. Okay, what are the synonyms? Okay. Okay, say unhappy or say poor. So does poor have the same lemma as verse? No, right?
No.
Okay, unhappy has the same lemma as verse? No, right? So they're synonyms, right? If you think about it, but in different contexts, yes or no? So how do you say that? Okay, these are synonyms. Any guesses? Like how would you do this task? Any ideas? Okay, let me give you a small hint. Let's say if two words like verse and poor, they occur in a lot of documents together, can I say they are likely to be synonyms? Yes, sir.
Yes.
Okay, would you see good or worse together more, or bad or worse together more, or poorer or worse together more?
Bad words.
So, we can check the frequency of a pair of words.
But you realize this, right? I mean, if two words are occurring more and more in a lot of web documents, can I say that they are likely to be synonyms?
Yes.
Okay. So the idea is there are models. What they do is they find a numeric representation for every word. Okay. They find a numeric representation for every word. So for example, if you look at the word verse, let's say I'm looking at a 10-dimensional representation. So I'm going to give you 10 numeric values like a vector, okay, of size 10. So this vector would be trained in such a way. So if two of the words, they occur frequently together in a lot of documents, what should be the distance between their embeddings, between their word vectors? Should be small or high? Think. If you are given the representation, you can say a numeric representation for a word, it should be small, right? Okay. So there is a model called as word2vec. What it gives is a vector representation for each word. Similarly, there is, so don't you think you can utilize it in the same way for the whole documents? Yes or no? If two documents are similar, don't you think their embeddings would be similar as well, like close by?
Yes.
Okay. So this model called as word2vec, there is an advanced version of this which is called as GloVe. Okay. This GloVe is like in further extension. So if you are looking at only the frequency, are you capturing semantics?
Only
If you are
frequency, on that time we were not looking at the semantics.
semantics, right? You're not doing the semantics, but it still works to some extent. So that is why this extension GloVe came, and it captures semantics at some level. Okay, so GloVe gave a better result than this. What we say is this word2vec. Okay, so we will see word2vec, we will see GloVe, we will also see sentence2vec. I will show you even advanced models. So you can get these embeddings for even what we say specific data sets.
So
don't
you're
you-
saying
Yeah.
that word2vec will give us the synonyms of the word, and the another one you said, like
Sentence.
that will give us the semantics and also the synonyms at the same time for
No. So what I'm saying is, see this word2vec model. Okay, what it will give you is if you give it at any input word, it is going to return you a specific length representation for that word.
Okay.
Does that make sense? Okay. In the hope that, okay, if these words occur together in a lot of documents, they should be closer to each other. Does that make sense?
Yes.
Okay. That is what the objective is. Now I'm saying that we can use the difference between these numeric embeddings to figure out if two of the words are synonyms or not. So if they are synonyms, their distance would be very, very small.
Yes.
That is the whole objective. Now there is a better model called as GloVe, which also gives these numeric embeddings, but it takes into account the semantics also. Okay,
Okay.
so Word2Vec does not take into account the semantics, it only looks at the frequency. This other model called as GloVe, it takes into account the semantics also. And then there is something called as Sentence2Vec. You can convert any sentence, paragraph, or a document to a numeric representation. And this representation is dense. Okay, so you can use these representations to get, to make a lot of applications. For example, say information retrieval. So if you think of maybe say a given document, if I compare its embedding with another document, can I say if they have a lesser distance, then they are the same?
Yes.
So you can use it for information retrieval, right? Recommendation systems like Google page ranking. So see, I search for some word here, okay? Let's say, give me, politics, okay? Say Rahul Gandhi, okay? And say, maybe say PM Narendra Modi, okay? So I'm going to search for these words, okay? So it returns these images, okay? And some documents here, okay? The idea is using these keywords. Do you think I can get an embedding? I can, right?
Yeah.
And I have these documents. Okay, I have these documents. I can get the embeddings from these documents. Whatever is the content in these documents, I can make an embedding out of it. For
Yes.
whatever documents I have crawled, I can compute the distance of the embeddings of those documents with the search query. And whichever are the nearest, basically the distance is the least, I can arrange them in a sorted order, in ascending order, and I can show the results. Let me tell you, this is how Google works. Okay, but there are many other aspects to it. Okay, computational aspects, resource aspects. And what we are doing is we are finding the, you can say, low dimensional representation of a given sentence or a word. And then we are matching. Okay, and then we are matching, okay, which are similar. And whichever are the most similar, that are retrieved. Okay, this is called as information retrieval. Simple suggestions. Okay, simple suggestions based on similarity matching. So I'll show you, okay, how to make use of it in the next class. Okay, any other questions? Any questions about this? I'll also show you how to train them. Okay, we'll not be discussing the nitty-gritties, but I'll show you, okay, how to train them, how to make use of it to build your own applications. Okay, but this will go slightly beyond data science. It will go into ML engineering side. But if you know about it, you can mention it in your CV. Okay, and you can say that, okay, I've used it in some of my projects. If you find relevance to it. Okay, if you find relevance to it.
Sure.
But there's such like several excellent models that are available. Any other questions?
No.
All right, then I'll just close this session and we'll meet, I think, next week, which is on
Yeah.
Monday. That will be like the last week. Okay, and we'll see a lot of these other applications also, which can be built on this text.
Okay.
All right,
Yeah. Thank you, Sanatan. Have a great weekend.
bye everyone. Bye Shilpa. Bye, take care.